Okay, so I'm having lots of fun recording this one. This is take 3 for some reason. So hopefully this will work out. And I'm unfortunately going to have to draw using the pen, which is never a great thing, but we'll make do. Okay, so anyway, so in this section, this is 12.2. So this is on branch. Drawing with a mouse is not good. Yeah, it's not going to work. I'm just have to talk. Branch and bound. Okay. So we talked before about backtracking. Okay. And with backtracking, the idea is that we're going to search for a solution that has some particular characteristics like the N-Queens problem, where we're going to go through and do a depth first. So we would start and then move away from the center with each solution in order to get where we're going. Okay. Where in the branch and bound, we're looking for optimization problems. Okay. So for the optimization problems, we have to make sure that we're getting feasible solutions. We have to get an optimal solution. So that's the new thing. Okay. So we have to track, okay, the best value of what we're trying to maximize or minimize at each point. Okay. And then those solutions, see what we've seen so far. Okay. So I can probably do some text here. So in this first case, we're going to have, we'll do an example of the assignment problem. Got job 1, job 2, job 3. Get that bigger. Okay, let me do that, maybe. There we go. Job 3. Let me space over now. And job 4. Okay. And we also have for each job, we have a person A. Person B. Person C. And a person D. Out of the way. Why won't we go out of the way? Yeah, I have no idea why it's not doing that. Okay, so we have values for each of these. Okay, this is a 9. That's a 2. That's a 7. And that's an 8. And for person B, we have a 6 to do job 1. We have a 4 to do job 2. We have a 3 to do job 3. And a 7 to do job 4. Person C is a 5818. Five, 8, 1, 8, and then person D, it's going to be 7694. And we'll see if that's close enough. Okay, close enough. Our person C is a little bit outlined. We get the idea. Okay, so for this, we're going to, this is the data we're going to look at, okay? And we're looking first at the lower bound for the entire problem, okay? So the lower bound of the problem then will be looking at the least cost for each row, okay? So that's 2 plus 3 plus 1 plus 4, which you can't see all those right now, equals to 10. Okay, so that's going to be the lower bound for the entire problem. The 2 in this row, the 3 in this row, the 1 in that row, and the 4 in that row. Okay, so the way we're going to approach this, okay, with our graph, we'll start here at the top. We have two parts here. The first is going to be the start. Okay, and then we're going to copy that with any luck and paste it. Okay. So at this start, our lower bound, again, is equal to that 2 plus 3. Well, we just did that, so it's 10. So we got the 10 there. Okay. Move that a little bit, line it up. Okay. So can I do all of that? Copy that. Okay, so at the first option here, at the first level, we're going to look at person A. Okay. If they take job 1, they take job 2, they take job 3, if they take job 4. Okay, we'll have to line these up a little better. And change the way things are done there. Okay, that's our 2. And there should be lines there, but I'm not going to worry about that because it's enough fun with the mouse as it is. Got 2 starts by mistake. Okay, let's get 1 start. Right there. Put the other start up there. These are all going to change. These values, the lower bounds are not correct. Okay, then we're going to go up here. Close enough. Okay, so again, our options here, in this case, we have that A is going to take job 1. In this case, we're going to have A taking job 2. In this case, we're going to have A taking job 3. In this case, we're going to have A taking job 4. Okay. And again, there'll be lines between all these, but that may be difficult to do. Just get the idea that this goes there. That wouldn't be bad. There. There. And there. Okay, so to calculate the lower bounds here for this first one. Why I did that, but okay. Oh, I've got the wrong tool. That's why. Go back to there. There we go. So the lower bound in this case. So we're assuming that, look at the top here, that A is taking job number 1. Okay. So that's going to be a 9 for that job. Okay. So we can't take anything else from that row, but we're going to take the lowest from all the other rows. Okay. I'm sorry, we're going to take this column. So job 1 is out. Okay. So we take the lowest in this row is a 3. The lowest in this row, not including column 1, is a 1. And then the lowest in this row is going to be a 4. Okay. That's going to equal 17. So the lower bound is 17 for that one. Okay. Now we're going to assume that A takes job 2. Okay. That's a 2 there. And then we do the lowest of the other rows, not including job 2. So that's a 3 plus a 1 plus a 4. Okay. Which equals to 10. We're still at our theoretical lower bound. Okay. So next we assume that A takes job 3. Okay. So that's a 7 for that one. And then that wipes out the 3 and the 1, which are our lowest before. So that's going to be a 4 for person B. It's going to be a 5 for person C. and it's going to be, there's a plus there. And then for person D, their lowest, not job 3, is a 4. Okay, which equals 20. Okay. So 20 for that one. And then finally, we assume that the person A takes job 4. So that's an 8 there, plus, and now we have the 3 is back in play for person B, plus the 1 for person 4, plus now the lowest is 6. We take job 4 out of the running, which is going to equal 18. Okay, so again, breadth first. We do this one 1, then 2, then 3, then 4, then 5. Okay, and we've now we can now determine that the way to keep moving is this one, right? Since we have the lower bound of 10, we're doing a minimization problem on our optimizing. Okay, so we can now, if we've made the assumption that person A takes job 2, person 3 now has 3 options. They can take 1, 3, or 4. Okay, so we'll move this one down. Okay, so we didn't determine that the other options weren't feasible, but we did determine that they were not optimal. Okay, so our graph looks something like this. That, of course, should go all the way. Okay, but in this case, we're not doing A's, we're doing B's. So in this case, B is going to take 1, or B, A is taking 2, so that's going to be a 3, or B will take job 4. Okay, calculate those new lower bounds. Okay, so if B, so we've got now, it's set in stone. Okay, if we go back up here, A is taking job 2. I didn't want to do it all that way. Well, that's unfortunate. What if I do that? I still can't. So that's all. Okay. Anyway, you get the idea. A is taking job 2. Okay. So the first number in all of these calculations is going to be 2. Okay, so there's 2 there. Just 2 there. And there's a 2 there. So that's that. Okay. So if we're looking at B taking job 1, that's a 6. Okay. So then we have to get the best from the other 2. So that's the person C then, not including 1 or 2. 1's the best number. And person D, it's going to be a 4. Okay. Which is going to give us 13 for this option. Okay. For B taking 1. Okay. So if person B takes job 3, okay, that's the 2 plus job 3 for person B is a 3, okay. And then we have the lower between jobs 1 and 4 for person C will be a 5 for a job 1, and then plus a 4 there, okay, which is going to be equal to 14, okay. Then if person B takes job 4, that's plus 7 there. And then that leaves person C, their best job. Okay, so we've got 4 is gone, 2 is gone. That's a 1 there. Plus person D would be a 7 there, okay, which equals 17. Okay, is the lower bound there. Okay. So let's now try to move some of this stuff up, make some more room, which could be fun. Okay, so now we've got that. Let's look. So again, when we look at these optimizations here, 13 is the lowest. Note, we can't do the 10. That was our optimal, okay, because job 3 can't be done by both of these, okay. I will say that you could, if you wanted, do all of this by going job based rather than person based. The job 1's taken by person A, B, C, D. You're going to get the same answer, just a different approach. Okay. So now let's look at what we have. So we now just come down to 2 options, and we can do those in one level. Okay. So let's paste there. Add one more row to that. That's the same basic idea. Okay. Paste one more time. Okay. And the reason we only have one more row here is that since there are only 4 in our example, if you pick C, you've picked D. Okay. Again, the assignment problem says that every person can only do one job. Okay. So what we have left here then, we can have C taking job 3, which implies that D is taking job 4. Okay. Again, we've got A taking 2, B taking 1. Okay. Or we can have that C is taking job 4, which means that D is taking job 3. Okay. So with the lower bounds here, we know that we're going to have the 2 comes from person A taking job 2. And we're going to have person B. Wait, am I coming off the right one? Yeah. The 13th, yeah. Person B is going to take the 6. Okay. So we have 2 plus 6 in both cases. Okay. So person C taking job 3 is going to be a 1, and person 4 taking job D is going to be a 4. Okay. Which gets us to a cost of 13. Okay. So over here, you have the 2 plus the 6. Okay. But person C is going to take job 4, which is an 8, plus person D is going to take job 3, which is a 9. Okay. Which gives us a total cost of 25. Okay. And these are not estimates, these are costs. Okay. Because we now have actual data. Okay. So then what that does. Interesting. Okay. So I guess, well, let's mark out. Let's go this way. So in this case, this was not a feasible option because of the lower bound. Okay. So we've gotten rid of these options because we calculated the lower bound and we only deal with the lowest one. Okay. So we tried person A with job 1, 2, 3, and 4. We looked at what the possible lower bound would be, okay, with that job taking out of the equation, and we get that A taking job 2 had the best potential score. We then looked at B taking 1, 3, or 4, okay. We calculated those. We found that option 3 led to a slightly higher cost, and that option 4 led to even more of a cost, okay. We then can put the last two together, since picking one assumes the other one, and it turns out that our lowest cost then for this particular assignment problem is going to be 13, okay. So person A takes job 2, person B takes job 1, person C takes job 3, and person D takes job 4, okay. So that's how that's going to work out. We have our inferior solution, and we have our superior solution being the lowest cost, being 13, okay. The book also has an example of the knapsack problem, okay. With that one, it has a table. It's on page 436. It goes through, and in that case, you're looking for each of the 4 items. Do you include them or do you not include them? Okay, then you're maximizing the value as long as you don't go over the weight limit. Okay, and then there's another example on the traveling salesman. So it's on page 438. Okay, and with that one, you're looking at which way you're going to travel. Okay, so do you travel first to whatever options you have? An example they give, you can go to 1 to 2 to 3 or to 4. So at each point you're looking at what's the possible next move that doesn't violate the problem. Okay, so that's it. Okay, as far as the material goes. Okay, so for homework, and these I want you to work on tonight, and we'll probably work on them in class tomorrow. Okay, going to be 5, which is a knapsack problem by Branch and Bound, and then 9 is also a Branch and Bound to solve the traveling salesman problem for the following graph. Okay, so 5 and 9 will be the homework for tomorrow, and that should be it. Okay, so if you have any questions on any of this, then we can certainly talk about it tomorrow. Okay.